Inequalities lesson 2. Let's continue on review from grade 9-10. Let's solve absolute value of 2x minus 1 smaller than 3. We know either x is greater than 1 over 2 or equal to 1 over 2, or x is smaller than 1 over 2. If x is greater or equal than 1 over 2, absolute value of 2x minus 1 and 2x minus 1 are the same. Therefore, we have 2x minus 1 is smaller than 3, which means x is smaller than 2. 2x is smaller than 4, x is smaller than 2. If x is smaller than 1 over 2, minus 2x plus 1 would be less than 3, because when x is smaller than 1 over 2, absolute value of 2x minus 1 and minus 2x plus 1 are the same. From here we have minus 2x smaller than 2. That means x is greater than negative 1. So if we combine these inequalities together, we have x is between negative 1 to 2. Between negative 1 and 1 over 2 is when the second inequality holds, and between 1 over 2 and 2 is when the first one holds. That means x is between negative 1 and 2. Generally speaking, absolute value of x is smaller than a when a is greater than 0, if and only if x is between a and negative a. Similarly, we can say if absolute value of x is greater than a and a is positive, we have x is greater than a or x is smaller than negative a. If a is a negative, absolute value of x smaller than a is impossible, and if a is negative, absolute value of x greater than a is always possible. That means the solution set of that is all real numbers. Let's solve a nonlinear inequality, 2x minus 1 over x plus 3 greater than 1. To solve this inequality, we bring 1 to the left side of the inequality and we take the common denominator. Therefore, we have 2x minus 1 minus x minus 3 divided by x plus 3 greater than 0. This means x minus 4 over x plus 3 greater than 0. If we use a sign chart, an interval chart, at negative 3, the fraction is undefined. At 4, the fraction is 0. For any real number greater than 4, x minus 4 over x plus 3 is positive. Between negative 3 and 4, let's assume x is 1, we'll see it is negative, and less than negative 3, it is positive. Therefore, the solution set of this inequality is x smaller than negative 3 or bigger than 4. Let's prove a2 plus b2 is always greater or equal than 2ab. We say this inequality is equivalent to a2 minus 2ab plus b2 greater or equal than 0, which is the same as a minus b to the power of 2 greater or equal to 0, which is always true. equality holds when A and B are equal. Now we use the inequality that we proved, and we show for any three non-negative real numbers A, B, and C, A2 plus B2 plus C2 is greater or equal than AB plus BC plus CA. We know A2 plus B2 is greater or equal than 2AB. Similarly, we can say B2 plus C2 is greater or equal than 2BC, and C2 plus A2 is greater or equal than 2AC. If we add up these three inequalities, we have 2A2 plus 2B2 plus 2C2 is greater or equal than 2AB plus 2AC plus 2BC. If we reduce it, we divide both sides by 2, A2 plus B2 plus C2 is going to be greater or equal than AB plus BC plus CA, which is a desired inequality. Thanks for watching.